Welcome back. In the first video, we'll install the OpenLane. In this video, we are going to do something incredible. Take a simple AND gate from a Verilog code all the way to the final GDS file that could actually be sent to a chip factory. This is the complete RTL to GDS. You will see how well you have designed a real chip. Let's get started. Here's what we are building: an AND gate. In this, there's two input A and B. As you see in the screen, the output is Y. The output is 1 only when both inputs are 1. This is the simplest logic gate, but the process will use work for processes with billions of transistors. Just we move on to one step-by-step flow, converting from Verilog to one GST file, the final result. Let me continue from what we done at last week. The folder which is already installed. Just wait. From OpenLane intro, then we going to inside the design. In this only we going to create a folder for what we going to generate a final GST file, and we check it about in a full flow what is happening till GST file has been created. Before that, we just open a CMD and we want to check that the Docker is opened or not. Otherwise, it's not work. Now, open your Ubuntu terminal first. Navigate to OpenLane. Okay, we just opened it out. Then check it out that Docker is working once. Otherwise, we're not able to run that OpenLane. Okay, working. Then we have to make mount to use OpenLane. Okay, now let's move on to now OpenLane. This means we have inside the container. We are all chip design tools are ready now. Second step is to create a folder and Verilog file to design a chip. Create a folder for an AND gate design. So we move into that. When you're doing that, the directory we design AND gate / source. We go to design folder. Yeah. Wait. There's a gate for this generator. CD and gate. Okay. Then inside that, yeah, source folder. Without Visual Studio itself, like touch, and gate. Okay. So module and gate. Okay. Inside that, it's just going to give an input A and B, and output is Y as seen in the A and B are the input and Y is an output. So which is going to give a module name with an input of and get input A, input B, output as Y. But they given Q. If you want to just Q also, it's based on your wish what letter you going to use here. Then just assign Q is equal to A and since I'm here, just this is a simple logic we're going to use, not more than that. Then and module. See, that's a simple code. Then use an API. We just try to code here itself. Not okay. It's just a complete colon. To save a file, you have to click W colon W. Then only the file saved. Otherwise, it's not saved. See, it's commit at a 3L75C it returns. Then we have to do escape and colon and then Q to exit the file from here. Okay, then check it if the files are saved or not by cat and get the see what we return inside the module is being shown here. Just touch config.json. Just use an API config.json and this we have to create an. If you feel to work in VI editor, you just open an Visual Studio Code and then you can use it. Since sometimes in VI, the what you typing is hanging. Just I opened and in a folder. In design folder only we just cross it out inside and there's a config file. You just open a notepad itself, add a PL target density now. Just to be show the position, just give 5 for FP core utility without any errors possible. Just why this one was again. For fabrication. Finally, this just shows a success completed. We check it by running the GDS file is generated by klayout. As the single syntax we can able to see about an klayout layout for the AND gate. Just see this the layout being see how it's confusing design for simple AND gate for in chip fabrication. Just simple layout for the see just the simple logic simple layout, but in this fabrication see how it's so confusing. See how many layers for it's being done automatically by itself during those 42 steps. See this much things is done automatically. We not do anything. We just done a simple code. We just only written this code and just we can't just done. But for that see how much thing is being generated on 42 steps. We need to use this. You can use a tiny tape out a GDS viewer. You can see in a 3D format. Just open the runner folder here and finally we just completed this working here. And as a result in final we go to GDS here and drag and drop the file here. Simply finished. This is the result we get final for one gate in chip fabrication. See how much is for this much small code. See in Verilog to convert to this is so simple in code, but really if you do separate software means you have to use for synthesis you need to separately For K layout you do separately, for substrate you have to do separately, uh, for preparing wire and preparing fabrication layout you may want to do separate tools, magic tools separate software you do. It's taking more time. So but in OpenLAN you just do by single code and using the flow, just flow command, it automatically convert all the processes into easily. So you can able to uh, send to a factory to do a design. So much easier than doing lot of work. This only is supported 130 nanometer, not supported for 2 nanometers. Thank you. See how much